स्टूडेंट्स आपकी बुक की चैप्टर नंबर 4 का प्रॉब्लम नंबर 4.5 आपके साथ डिस्कस करना चाहूँगा। तो ये एक फिगर गिवन है, ठीक है, वेयर टू मैसेज आर कपल्ड लाइक दिस एंड वी नीड टू फाइंड दैट देयर फ्रीक्वेंसीज ऑफ ऑसिलेशन आर दिस वन। सो हमें फाइंड करना है कि फ्रीक्वेंसीज ऑफ द नॉर्मल मोड्स ऑफ वाइब्रेशन आर दिस वन, ओमेगा स्क्वायर इक्वल्स 3 plus minus square root 5 into s over 2m। तो इस फिगर में अगर आप देखें, so there are two masses, okay, we assign the displacement of upper mass as x and we assign the displacement of lower mass as y, okay. So if we look at this figure, we see that the upper mass is attached to two springs while the lower mass is attached to only one spring। इस फिगर में अगर आप देखें तो आप देखें कि जो अपर मैस है ये दो स्प्रिंग्स के साथ अटैच है और लोअर मैस इज अटैच्ड ओनली टू वन स्प्रिंग। और जब आप इसकी इक्वेशन ऑफ मोशन लिखेंगे तो हमें इस चीज़ का ख्याल रखना पड़ेगा। अच्छा, so first I write the equation of motion for the upper mass. Okay, it would be like one term from Newton's second law of motion, then Sx, okay, plus S into x minus y equals 0, and I label it as equation 1। अब देखें कि first we write equation up to here, okay, so it is the same case as the mass attached to a single spring, ठीक है। तो इसकी इक्वेशन हमें पता है हम कैसे लिख सकते हैं, mx डबल डॉट प्लस sx, ठीक है, but it is also attached to lower spring also, so we also need to write this term in which the displacement, resultant displacement would be the difference of these two displacement, okay। Similarly we will write the equation of motion for the lower mass, and we know that lower mass is attached to only one spring, okay, so there will be only two terms. One would be from Newton's second law of motion and minus s into x minus y equals 0. So we need to write its displacement as a difference of these two displacement because y is dependent on x. So if x will change, then y will also change. So we have written here the difference of two displacements. Okay, these are our two equations, and now we need to solve these equations to find the value of the omega. So we assume that the solution of these two equations are x equals a e to the power iota omega t and y equals b e to the power iota omega t. Okay, if masses start from the rest, then we can assume the solutions like this. Okay, if these are the solutions of this equation, then these solutions should satisfy our equations. So putting the values of x and y in our equation, so we need to find x double dot and we also need to find y double dot so that we can use it in equation 1 and 2. Okay, so if I will put these values, so I will get the resultant equations as, so I will get minus m omega square a plus s into a minus b plus s into a, and I have taken here e to the power iota omega t common, which is equal to 0. And similarly from equation 2 I will get minus m omega square b minus s into a minus b. So I have also taken here e to the power iota omega t as common. Okay, so I can solve it. I can label it equation 3 and I can label it equation 4. I can solve it further. Okay, so if I will solve, I will separate the values of the a and b, so that I can take a and b common from these terms. So it will be equal to minus m omega square a plus sa minus sp plus sa equals 0. Okay, I can solve it further. So this equation would be minus m omega square a plus sa, and sa would be 2sa minus sp equals 0, and it will further equal to, if I will divide the whole equation by m, and also I will take here a common, so it will be 2s over m minus omega square into a minus s over m into b equals 0. So I can rearrange my equation. Okay, I label it as equation 5. Similarly, from equation 4 I will get, so minus s by m to a plus s by m minus omega square. I have taken b here common, so that's my equation 6. So now I can write the matrix equation from equation 5 and 6. So I can write the eigenvalue equation from equation 5 and 6. So it would be equal to 2s by m minus omega square minus s by m, then this term minus s by m, and then the term of the b, that's s by m minus omega square. Okay, that's my first matrix, and then I have my column matrix A and B, and which is equal to 0. Okay, so that's, if I will solve the equation, so this equation 7 will have solution only if the matrix, if the determinant of this matrix is equal to 0. So I will find the determinant of this matrix, so I will multiply only the diagonal terms. Okay, so it would be equal to 2s by m minus omega square s by m minus omega square minus s square over omega square. I have multiplied these two terms, diagonal terms, and then these two diagonal terms, and which is equal to 0. So if I will solve this equation, so I will get the value of omega square 3 plus minus square root 5 into s over 2m. So that was the result which was required. Okay, so in the second part we have to find the ratios of the amplitudes. So we need to find the amplitudes A and B and then their ratios. So in this term there would be two modes. One mode would be the faster mode and second one would be the slower mode. So the faster mode would be 3 plus square root 5 s by 2m, but the frequency of the slower mode would be 3 minus square root 5 into s over 2m. So if I will use these values of omegas in my equation 7, so I can get the values of A and B, and then I will be able to find the ratios of A and B both in the slower mode and also in the faster mode. Okay, I leave the remaining portion for you. You should try to solve it. If there would be any problem, then please ask me during the live session.